welcome to our fourth and final video for 6-4. In this video we are going to be given a graph and we are going to look at two different forms of an equation and try and figure out which one matches the graph. So the way we're going to do this is we're going to be given some specific hints of some characteristics to find to help us see which one matches. So the first characteristic you'll see in both of these equations is that we're asked to find the vertex. Now my first equation is given to me in standard form. F of x is equal to x squared minus 5x plus 4. So what I'm going to do is I'm going to use my negative b over 2a. So I'm going to plug in and get negative 5 over 2 times 1. That's going to give me a positive 5 over a positive 2. And what I'm going to have to do next is to go ahead and to plug this in and find what the y value of my vertex is. So I'm going to plug in 5 halves squared minus 5 times 5 halves plus 4. I'm going to square my 5 halves x, or 5 halves squared, and that's going to give me 25 over 4. Minus, I'm going to multiply these and get 25 over 2. And then I'm going to add 4. Now I have to have a common denominator to be able to add these. So it's going to be 4. So I'm going to do 25 fourths. Plus, to get a 4 on the bottom here, I have to multiply top and bottom by 2. So that's going to give me 50 over 4. And then remember 4 over 1 is going to be how we would write 4 as a fraction. So to get 1 to be 4, I'm going to have to multiply it by 4 on top and bottom. And that's going to give me 16 over 4. I can add these together now. That's going to be 25 plus 50 is going to be 75. 75 plus 16 is going to be 91 over 4. So my vertex is going to be 5 halves and 91 fourths. So 5 halves would be 2.5. And I am going to look to see if that matches. Right now it doesn't look like it's going to match. But let's go ahead and look at our other characteristics just to be sure. Now the vertex form from our vertex form equation is of course going to be a lot easier. We can pull it straight from here. Remember that the h is going to be right here and the k is going to be right here. Remember that minus is part of the original equation. So this is actually going to mean that this is a positive 3. And then when we have our 2, that 2 is not going to change, so our vertex is going to be positive 3, 2. Next thing to look at is the extrema. Remember, the extrema will match the vertex, but what we want to look at specifically is whether these are going to be maxes or mins. Now, our a value for our standard form equation is going to be positive, so this means that our extrema is going to be a max. Sorry, I misspoke there. The positive a value means that this is going to open up, so our extrema would be a minimum. For the other hand, I think this is where I was thinking ahead to, our vertex form has a negative a value, so it's going to open down. Now since it's going to open down, our extrema should be a max. Now just checking things so far, it does look like this is going to be the best match for our graph. We do have a vertex at 3, 2, and this is going to be a maximum. But just in case you were asked to look at an example that wasn't quite so clear, let's go ahead and look at the roots as well. So on this, for our standard form, the best way to find our roots is probably going to be to factor. This looks like a problem that will factor fairly well. So when I factor this, I have a coefficient of 1 on my a value, so I don't have a GCF, but that does mean that I can lock in my x and my x. And I have a positive symbol here, so this is either going to be both pluses or both minuses. And I have a minus in the middle, so that's going to give me 2 negatives. So I'm going to use my 2 negatives. Now for I can do 2 and 2, or 1 and 4. Now knowing that I have to be able to get a negative 5 in the middle, I am going to go ahead and do the 4 and the 1. I would solve these by saying them both equal to 0. and I would get x equals a positive 1 and x equals a positive 4. You could also use quadratic formula or any other of those methods that we've used to go ahead and find this. But we can see that this definitely does not match it. So let's just double check our roots over here. Now, to figure out the roots on a standard form, a vertex form, your best bet will probably be to convert it to standard form. That way you can either factor or use the quadratic formula. So that's what I'm going to do. I'm just going to rewrite my equation up top here as x minus 3 times x minus 3. And then I'm going to have the plus 2 at the end. The next thing I'm going to do, make sure I bring down the negative, but I'm going to distribute out these pieces. I'm going to get an x squared minus 3x by taking this and distributing it to both pieces. Then I do both of them with the second piece, and that's going to give me another negative 3x and a positive 9. And I have a plus 2 at the end. Now I am going to go ahead and use the negative down here. Combine like terms, x squared minus 6x plus 9 plus 2. And I distribute my negative. That's going to give me negative x squared plus 6x minus 9 plus 2. So that's going to give me negative x squared plus 6x minus 7 is going to be what my function is. Now this does not look like something that is going to be easy to factor, so I am going to use the quadratic formula on this. So I am going to plug this in as negative b, so negative 6 plus or minus the square root of b squared minus 4ac over 2a. I'm going to simplify. That's going to give me negative 6 plus or minus the square root of 36. I have 3 negatives, so that means I'm going to get a negative. And 4 times 1 times 7 is going to give me 28 over a negative 2. So that gives me a negative 6 plus or minus the square root of 8 over negative 2. Now I want to go ahead and to simplify this as much as possible. So if I look at 8, that breaks down into 4 times 2. 4 is a perfect square, so that 4 can come out to the outside. We take the square root of 4 and we get 2. We're left with this 2 on the inside over negative 2. Now we can look at these 3 pieces and see that a 2 will go into all 3 of them. So that's actually going to give me negative 3 plus or minus the square root of 2 divided by a negative 1. And if I were to type these into the calculator, I would go ahead and do that. And let's see what we get. Negative 3 plus the square root of 2 and then divide by a negative would give us about 1.58. And then if we did it with the plus sign, with the minus sign, negative 3 minus the square root of 2 is going to give us about 4.41. So I will write that out there. So let's go ahead and check with these up here. It does look a little bit more than 4 and a little bit less than 2. So I would say that this is a good call for our matching equation. Alright, there is no you try for this video. Go ahead and do the practice. Let us know if you have any questions, and we'll see you in the next lesson.